Okay, I think now everybody should be here and we can start with the webinar about graph layouts and yFiles. Today I would like to give you a high-level overview on graph layouts and which is the starting point of an entire series on graph layouts, on webinars on graph layouts. And then in these webinars I will then give more details about the single graph layouts. So first of all, I would like to introduce myself. My name is Benjamin Niedermann. I'm a software developer at yWorks, and I work in the team of the layout algorithms, which basically means that I work at the very core of the layout algorithms. And as I already said, I would like to give you a high-level overview of the graph layouts and yFiles, but before that I would like to give you a short introduction to yWorks and yFiles, and then after giving also the high-level overview of the graph layouts, there will be the opportunity for you to ask questions, which I will try then to answer. If you have some questions during the webinar, then please feel free to ask them in the chat, and then I will try to answer them after the webinar. So first about yWorks and yFiles. yWorks is a company that was founded in 2000, and this company is located in Tübingen, which is in the southern part of Germany. And currently we are more than 35 employees, and we are the leading developers for diagramming solutions and libraries. So there are more than hundreds of corporations around the world that trust our product and use yFiles and also the derived products of yFiles for their own solutions. Here you can see a very short list of these companies. Altogether, there are customers in more than 60 countries, and we have more than 1 million users, and we have over 1 million, or we have millions of downloads for our diagramming editors like yEd. Maybe you have already heard this tool. And all these products that we develop at this company are based on one huge library, one huge diagramming library, which is called yFiles. And this library can be used, for example, for HTML, for JavaFX, Swing, .NET, but also for WPF. These are the 5 main platforms, but there are also other platforms that are supported. And this directly brings me also to yFiles, the diagramming library, and which I will shortly introduce on the following slides. So the library is an SDK that can be used, as I already said, on different platforms, and this is for visualizing connected data. So when we talk about graphs, we do not mean bar charts, pie charts, or function plots like shown here in the right corner, but we really mean connected data. So we mean networks that consist of nodes, and these nodes are connected with edges. A very simple example is our social networks, where each node is a person, and then there's an edge or some connection between the nodes when the persons are friends, for example. So, and our library gives you the possibility of visualizing such kind of networks, and not only social networks, but also entirely different networks, as you will see later in the slides. And this is, for example, also very important for graph analysis, but also maybe you would like to just visualize your network you're using. And the very nice thing of this software library that we have developed and are still developing is that you can use the layouts automatically. So this means basically that you can input the graph, and then you get automatically some graph layout for this input. And of course there are many possibilities to configure this layout algorithm, but basically you don't need to do too much to get some nice layout. And of course there's also the possibility to introduce interaction, but also animations, which you will also see later in the webinar. So the supported technologies and platforms for yFiles are web applications. So we have the product yFiles for HTML. Later on you will see some coding examples in this library yFiles for HTML. But you can also use yFiles, for example, for Java and JavaFX, but also for the .NET platform. So for example for WinForms, but also for WPF. And this brings me directly to the basic or the core topic of this webinar, namely the graph layouts in yFiles. So maybe you already have some experiences in these graph layouts, and then you know that there are many different types of graph layouts that you can use with the yFiles library. So for example, there are some kind of hierarchic layouts, tree layouts, orthogonal layouts, but also the organic layout. And then there are also some very specialized layouts like the series-parallel and for example, the tabular layout. And in this webinar, I will talk about how to use these layouts, in which cases you can use them, but I will also show how you actually can use them in your source code, so how to configure these. So one big question is, which layout should I use? And in this webinar today, I will mainly talk about this. And then the question, how should I configure it, is an important question that I will also answer in the subsequent webinars. So just giving you some very short overview how we have planned these series of webinars on graph layouts. So today there's this overview webinar. And in this webinar I will give you some high-level overview, and basically we will discuss layout properties and discuss when to use these layouts. And I also will give some minimal code examples showing you how to use them in yFiles HTML. If you are more familiar with Java or with WPF, so with C#, that's no problem, because the library itself uses the same terminology. So basically, if you can understand these HTML examples as well when you normally program in C#. There are only slightly differences that are not that difficult. After this overview webinar in September, there will be a webinar about the hierarchic layout. Then in October, we will discuss a new layout which is introduced with the upcoming release of the HTML SDK. And then in November, there will be also a webinar about the tree and balloon layouts. And this is basically the plan for this year. And for the next year, we haven't fixed the schedule yet, but we are planning to do some webinars on layout algorithms. But you may also give us some feedback. So for example, if you would like to hear something about a special layout, then you can just write us some email, for example, or you can write this into the chat, and then we will try to arrange this in the schedule. So all of these webinars after this high-level overview webinar today will have a very similar structure. Namely that first of all we will discuss the principles on these layouts. So how are they created? What are important properties of these layouts? Should I take care of when I use them? This especially includes also use cases. And then there will be also always a part where I will show the basic setup of these layouts, and this is always a live programming example that I will give in yFiles HTML, so that you actually can see how to use this in your programming interface. And then at the end of this webinar, I will also give some outlook on the layouts and on more advanced techniques. And if you're now curious about how this could look like in practice, so and what this does mean, what it means in a concrete way, then you can just have a look at published on YouTube, namely in March, and you can just access this, for example, via YouTube by just searching for webinar and yWorks. You will find it easily, or you can have a look on our webpage, and there you can also find it very easily. And this webinar basically has the same structure, and it's already a presentation of the organic layout. But today I would like to give you some overview on the graph layouts and discuss them shortly, so that you get some idea when to use them and how to use them. So when we have all these layouts and we have some graph and we need to decide on which of these layouts we need to or we should use, we should of course already know what kind of layouts are offered by yFiles and what kind of properties they require and what kind of visualization properties they give you if you use them. So, and in the following part I will discuss them step by step. Some of them I will discuss only as a single layout, some of them I will discuss them in a group of layouts. And I would like to start with a very generic layout, namely the organic layout that you can see here on the right hand side. And as I already said, there's already some YouTube video that you can watch if you are interested in the details of this layout. So a typical property for the visualization is that the nodes are distributed in a natural way, and symmetric properties are also emphasized. So for example, here you can basically see that the neighbors of one node are placed very closely to one node. And further, what you also can see is that the edges are straight lines. So basically this means that there's no special edge routing between the nodes, but only simple straight lines are used. When you create your layouts, you should always be aware of this. Sometimes it's an advantage to have these straight line connections, especially if you would like to visualize connections between neighbors, then this can be a real advantage. But if there are many edges, for example, going from this node to this node, then to some nodes here in this part, then maybe straight line connections are not that useful, and you want to use another layout or some other layout. But basically, it gives you already some very nice visualization with some natural distribution. So typically this is used for large networks, for example. So this is a really fast layout algorithm in the back, so, which you can apply on large graphs. So this also means that it's applicable for social network analysis and also, for example, in bioinformatics. I also would like to emphasize that this organic layout, as it is implemented in the yFiles layout, in the yFiles library, can also emphasize substructures. So for example, what you can see here is that this organic layout has some cycles, and these cycles are specially layouted. So in this graph structure we have a cycle, and this cycle is placed on a geometric circle. And also the same applies, for example, for star structures, but maybe also tree structures can be emphasized using the organic layout. And the very nice feature of this layout is that it has no limitations, in the sense that you can input every graph and you get some kind of layout. Especially if you do not know the structure of the graph in beforehand, which may happen sometimes, it's always a good idea to first apply the organic layout to maybe get some idea on how to proceed and which and to see which of the layouts could be a good choice for this graph. The next layout that I would like to discuss is the hierarchic layout, which is also a very generic layout in the yFiles library. Here the idea is that the nodes are placed in layers. So for example, this node is placed in the topmost layer, this is placed in the second topmost layer, and so on. So basically you can imagine a horizontal line going through the centers of the nodes, and this defines the layers of the nodes. And what you can basically see in this layout already is that there is a flow from top to bottom. And this flow is typically for these hierarchic layouts. So typically you would like to apply this layout on graphs that have a lot of directed edges, and where you already know that there is some kind of flow that goes maybe from top to bottom or from left to right. And there are only few edges that basically contradict this direction or this flow. Then further feature that I would like to mention is that it also allows different edge routing styles. So for example, in comparison to the organic layout, which only allows straight lines. And here, for example, you can use polylines for the edges. So basically you can introduce some kind of bands, which gives you some kind of flexibility to place your nodes. And of course, this placement is done automatically, but this basically means that the layout algorithm can use the space a bit differently. And as similar to the organic layout, there are some subcomponents that can be emphasized. So for example, here you have these orange nodes, and these orange nodes form a tree. So in a graph sense, a tree, which means that there are no cycles if you look at this subgraph. So if you look at this substructure, there are no cycles, so there is no edge, for example, from this node to this node. And this means that this has a special structure, and such kind of subcomponents can be identified by this layout algorithm automatically, and then these are emphasized in the visualization. The same applies, so for example, for the star layout, but also for subcomponents that are again hierarchic layouts. So for example, the top level layout has a flow from the top to bottom. So here the main edges go from top to bottom. But in this component with a brown color, here the edges go from left to right. So basically you have a recursive definition of this group here. And where do you use these hierarchic layouts? Typically you use them in flowcharts or decision diagrams, but also in process modeling, UML, and activity diagrams. So for example, here you have a typical UML diagram where you have a flow from top to bottom. It's a very simple graph actually, but there you would like to emphasize this temporal order of these nodes, for example. And at the same time, there's some kind of order from the left to right, which is expressed by these swim lanes. So this layout, for example, also supports swim lanes. So you can define swim lanes, which means these lanes here, this white lane, this brown lane, and this white lane again, where you can place the nodes, and then the nodes stay within these lanes, and the layout uses this space to create a layout as good as possible. And for example, in this webinar that comes in September about the hierarchic layout, I will also tell you how to use such kind of techniques in order to get some figures like this, but maybe even, of course, a bit more complex. So the properties of the graph, basically there is no restriction on the graph, similar to the organic layout. You can input any graph and you will get some results. But typically you would like to input graphs that have some directed edges, and typically these graphs should already have some kind of structure. So it should be clear that there's some, for example, flow from top to bottom or from left to right, which is basically only a rotation of the drawing, so that you can or so that you already know there is some kind of hierarchy in this layout. In contrast, I would like to present now two other layouts which are really restricted in the properties of the graph. Namely, while the organic layout and the hierarchic layouts, which I just presented, can be used for any graph, these two layouts can only be used on trees. Again, in graph theory, a tree is a graph that does not contain any cycle. So for example, here you have a very classic tree structure, and if I introduced here an edge from this node to this node, then I would have here some cycle, and then this wouldn't be a tree anymore. However, these kind of tree structures often occur in applications. So for example, if you have a very simple hierarchy where you have some kind of ancestors and so for example some parents and child relations, then you typically get these kind of tree structures, and then it's nice to have some kind of specialized layout that can take this into account. And in yFiles there are, among others, two important layouts for trees, namely the tree layout and the balloon layout. The tree layout basically assigns the nodes to layers from top to bottom, for example, but it can also do this from left to right. And then you know that the parent node lies above children nodes, and so on. The balloon layout also creates a tree layout, but here the idea is that the nodes are placed in a radial fashion. So for example, this could be the root node, so in this case it would be the topmost node here. Here we have the root node in the middle, and then the children of this root nodes are placed regularly around this root node, and so on. This is again done for the children and their children, and then you get this kind of radial layout. So parent and child relationships are emphasized, and so for the typical use cases, you can consider, for example, network management or business administration, where you have some kind of organization charts, and here you have, for example, some groups where you have some members in the groups, and maybe these members are again some groups, and you again have some members. So you get a very clear hierarchic layout where, for example, this node has no connection to this node. And these are typical tree layouts, and as I already said, the very important thing about this is that the graph is an actual tree and may have no cycles. And as you will see later in the coding example, you can specify a dedicated root node. And is it always true that you can always apply it only in trees? Yes, that's true, but you can use a tree reduction stage to support graphs that are not trees. But here you need to be aware that this should be only done if it has few more edges that make or that create cycles. Here basically the idea is that these edges that create cycles in the graph are hidden, so that are hidden, such that these are not seen by the layout algorithm, and then the layout algorithm applies this tree layout, and then after that the edges are introduced again. The next two layouts that I would like to present are radials and circular layouts. They are basically layouts that support or which also result in very tree-like structures. However, they support arbitrary graphs again, where you have also some cycles. So for example, in the radial case, the idea is that the nodes are placed on concentric circles, so all circles have the same center. Here we have some center node, and then the next circle is placed here, and the nodes are placed on this circle, and so on. And the idea is again that this radial layout is very suitable for tree-like structures. However, this time you can also have edges that form or that create cycles in this tree structure. On the other hand, the circular layout here, the idea is that components, so-called bi-connected components of the graph are represented by cycles. So for example, here this component of nodes, which is not a tree structure, is represented by a cycle. And this is done for all of these components. So here it's a very clear emphasis on cycles, and then the cycles are connected via the other components which are more tree-like. So it's basically a combination of a tree layout with some cycle layout. And the question is, when can you use them? So okay, this is the nodes are placed on concentric circles or arrays, as I already said, and it's a very clear emphasis on group and tree structures what you get. And typical use cases are, for example, social networking or some kind of other network management. So for example, here in the upper corner you see this radial layout, and what you can, so there are no labels for this visualization, but the center node, for example, represents an airport in Germany, namely the airport Frankfurt, which is one of the largest airports in Germany. And then the next circle shows the airports that can be directly reached by this airport in the center, so with a direct flight. And then the next airports that can be reached with one stop, so in 2 steps, are placed on the next circle, and so on. So basically what this gives you is the possibility of representing such kind of hops that you can do, for example, to reach another node from the center node. So always you have this dedicated node in the middle, and then you can go outwards. Here in this example it's also very small, but the idea is that each node is placed on the very outside of the circle, and each node represents a person, and then you get a connection between 2 persons if they are friends. And which gives you here a very nice layout, because we also used edge bundling for this layout. So when should you use these kind of layouts? They are well suited for directed graphs and tree-like structures. So again, there should be some kind of a tree structure in this, but they don't need to be exact trees in this sense. And they really nicely show interconnected ring and star topologies like the circular. Here you have these stars which are connected with a root node. Here I would like to go from, so the last 3 layouts, so the balloon layout, the circular radial layout, and the circular layout, always place the nodes on circles. Here this layout, or these 2 layouts, take a different approach, namely that they use a kind of grid where you can place the nodes such that the edges always are orthogonal. And orthogonal means that each segment of an edge is either horizontal or vertical. So for example, if you go along this edge, one segment of this edge is vertical and the other is horizontal. And this applies for any of these edges in this layout. And this is, for example, very nice in technical drawings where you need to have a very clear structure and where the emphasis is also on the edges, so that where it's really important to follow these edges. Typically, or what you get is are drawings with no overlaps between the nodes. So for example, here you won't find any node because no overlaps between nodes, because the layout algorithm really ensures that there cannot be any overlaps. So for example, for the organic layout, in contrast, there you can enable an option that allows node overlaps, which can make the drawing a bit more compact. Further, it's not always possible to avoid all crossings between edges, but typically this is optimized by the layout algorithm. So you only get few crossings if this graph that you input allows this. And the same also applies for the bands. This is basically optimized by the orthogonal layout algorithm, the number of bands. And the series parallel graphs, so this basically applies for the orthogonal layout. And then there's also the series parallel graph, which I haven't discussed so far. So the series parallel graph is basically a special case of the orthogonal graph. Here the idea is that you have special structures like nodes that follow in a row considering the edges, so they form a path or they form parallel structures. Therefore also this name series parallel, only serial structures and parallel structures that can occur in the graph. But basically it's also an orthogonal layout. However, due to the structure, you can exploit this a bit more, these properties, obtaining a bit more compact layout, for example. And this is a very special case which may occur, for example, in technical drawings. So if you would like to use the series parallel graph, you need to be really sure about your graph structures. While the orthogonal layout in general can be applied on any graph that you input. So typical use cases are software engineering. So for example, in the series parallel case, you get some kind of structure that, for example, in some kind of UML diagrams, you can find such structures. But especially the orthogonal layout are used for technical drawings, database schemas, and also for system management, where you need to get a really clear structure on the nodes and edges. It's very similar actually to the hierarchic layout. However, it does not assume any flow from top to bottom, for example. And yeah, typically you can apply the orthogonal layout, for example, on medium-sized graphs. For large graphs, you normally get a problem, or you get problems with the number of bands, because if you assume, for example, that you have many nodes and many edges, then you need to circumvent these nodes with many bands. So if you have two nodes that are far away in this drawing and you would like to connect them with an edge, then you need to introduce many bands and crossings, and this becomes more problematic when the graphs become larger. But for small and medium-sized graphs, this layout works very well. And the series parallel graph is an orthogonal graph with a very special graph structure which allows some special kind of layout. Here, for example, it's again that you have a flow from top to bottom. So there's only one source node and one target node or sink node. This brings me to even a bit more specialized layouts, namely the compact disk and tabular layout. Here the idea is that the nodes are placed, for example, on a disk, and are placed in a very compact way. And for the tabular layout, the idea is basically the same, but it's not a disk but a rectangle where you place the nodes. And here the idea is that the nodes are placed either both in columns and in rows, so that you get really a tabular layout of this. One note about the compact disk first. This is a very new layout which will be published in the new release in yFiles HTML, which is upcoming. And both layouts, as you may already have assumed, are basically good for node placement, where edges play a minor role. So for example, if you consider this layout, it's really difficult to introduce new edges, but sometimes it's completely sufficient to just place nodes to express something without showing too many edges. Here, for example, there's another example. for the compact layout, for the compact disk layout, with some edges. And as you can see, there are many different connected components, mostly paths, and some of them are not paths, but still they have only few edges, so that the edges do not cross the entire drawing. So if you introduce too many edges, this is typically what happens, is that you get edges that go through the center of this disk. So then the question is, if you cannot draw too many edges, why should I use this? Or the same applies for the tabular. And the answer is, it gives you a very compact visualization of group content. So assume that you have some kind of group nodes and they contain further nodes. And these group nodes and the external nodes are placed, for example, using the organic layout. And internally, you can place the child nodes using the compact disk layout, for example. And if they only have few edges, this works quite well. And the sizes of the nodes already give you some impression how many nodes are inside of this group. And it gives you already some kind of structure. So for example, here you can see that there are no connection at all, while here are some few connections. And so this basically gives you some kind of visualization that gives the viewer of the drawing some kind of hints about the group. Another scenario where you can use it is interactive scenarios. So for example, if you hover with your mouse over a node, you may show the edges, while for the other nodes the edges are not shown. So summarizing, I would say that the properties of the graphs that you can use for these layouts should have small components and low connectivity, but then they become really interesting layouts because they are able to make drawings really compact. Finally, I would like to introduce also a very new layout, which was also published with a new release of yFiles HTML. And here the idea is that we would like to visualize grouping structures. And the idea is here that you have one node here in the middle, which is a really large group. And this group contains all these nodes here outside of the group. But typically you visualize these groups by drawing the children of this group inside of this really large group node. But this layout takes another way by just placing the nodes on the border of this group node. And this is done recursively. So for example, this is again a group node, and the children of this group nodes are placed on the border of this group nodes, and so on. And this gives you this typical fractal layout, which also gives this layout its name, namely it looks like a cactus. And what you also can do is you can show the edges of the nodes in between the groups. So this is basically an alternative visualization of group hierarchies, and it, for example, provides you with the possibility that you can recognize similar substructures very easily. So for example, here you have some kind of tree or subgroup that you can basically find here again. Maybe the edges are not completely equal, but it shows that there's some group that has again the same structure, the same substructure. So why should you use cactus groups? So for example, for graph explorations, interactive graph exploration, here you can really use it. So for example, you have this group node here, and then the user clicks on the children of this group node and enlarges the children. And each time a child is enlarged, it shows its own children, and so the user can proceed with this and explore the groups and get some feeling for this deep grouping structure here. And this is basically the entire graph then, with this deep grouping structure. And of course, on the one hand, it's a really nice eye catcher, but it really gives you also an impression on how the groups look like and how the hierarchy of this grouping structure looks like. So this is all about the high-level overview of these layouts. In the next part, I would like to give you some examples, some coding examples, how to apply them. But I would like to remind you that if you have questions about these layouts, please feel free to use the chat and just ask your questions, and I later on will try to answer them. So this brings me to the coding example. And in this coding example, the idea is that I will only show you a minimal code example for how to use these layouts in yFiles HTML. And this will be the base for the upcoming webinars, so that we can use this example also for the other webinars. I would like to start with a very simple demo. So when you use, for example, yFiles HTML, you get a really large set of demos. And these demos can be used to learn how to use the layout. So there's a really big list of different examples that you can use for your own purposes. You can adapt these examples, and this is always a good starting point if you would like to use some kind of layout, or you would like to use something else of yFiles. Then I always recommend to have a look at these demos and to see whether there are already some similar problems solved, and then you can get some idea. And the demo that I would like to consider is in this folder tutorial getting started, and there's this folder layout, and then here there's this file sample applications. And I only made a very small change in this file so that I can use it for the webinar. Namely, there's this method run layout, and I just deleted the entire content of this method. Before I talk about this method, I would like to give you a short overview of this file, how it looks like and how it works. So at the beginning there are some kind of imports. If you know Java, for example, or C#, it's very similar. You have some imports for the basic, or for all the objects or classes that you would like to use. And then there's some method one which is called when the demo is started. And I can also show you how this looks like. So I just press the run button, and this is what the result is. So basically you get a website with some editor. You can, with a graph in this, and you can move the nodes. And as you already can see, the layout of this graph is not very nice. So we need to apply some layout on this graph. One moment. So, and when this web page is loaded, this method is run, and here several things are done. There are some setups that needs to be done, and then there's some method that is called, it's called create sample graph. And in this method, if we jump to this create sample graph, there the graph is loaded. And here I just load an example. It's called example hierarchic, and here, basically the graph is built. And then there's this other method, run layout. And this method is always called when the layout, or when the website thinks that the layout needs to be recreated such that it can be viewed again. And currently nothing happens in this one layout, and so no layout algorithm is applied on the graph, and this is also why it looks really really chaotic. And now I would like to show you how to apply a layout on this graph. The first thing is that we need to get the graph, and for that, we call the graph component, and this graph component is basically the basically this component that shows the graph, and this has the graph as just as an attribute, and we just take this graph so that now we have access to this graph. And the next step is that we would like to apply a layout on this graph. So for example, we don't know any structure on this graph, so we will just start with an organic layout. And it's just called organic layout. I need to add some import statement, and this is all. There's no configuration for this layout, which we would like to apply at the beginning. We just want to apply it. And then in the next step, we apply this layout on the graph. To that end, we call apply layout of the object graph. And this is already all what we need to do, and we can start this again. So this is the method, and now we press the layout button, and this method, or when I press this layout button, what happens is that the layout algorithm is called. And this is basically the result. And again, already if you have a look at this result, you can already see that there are some kind of directions in this graph, so maybe it's worthwhile to use the hierarchic layout. So we can change this to the hierarchic layout, and sometimes it's really it's reasonable to just try some of these layouts, and it's really easy to change this this layout, which is really nice. One moment. And if I press this again, now we get a hierarchic layout on this graph. So we have these topmost nodes, and the nodes are placed in layers from top to bottom. And in the next part of this coding example, I would like to show you how to configure such layouts, so what the typical ways are, giving you some very simple examples. But before I do this, I would like to introduce another thing that it's really nice. I would like to introduce some animations so that when I press the layout button, it looks a bit more nice. So that the animation changes animated a bit. So what I can do is that I wait. I can do this layout on a morph. I'm sorry. So I will explain this in a few seconds what I'm doing there, and then I will tell you a bit more about this. So the difference is now that to the approach before is that I do not want to just apply the layout, but I would like to do some morphing between the input layout and the output layout, just for visualization purposes. And to that end, I call the graph component, and this graph component has this method morph layout, and this method expects the layout, then also some kind of duration, how long the morph should take, and then I also can say that it should be an east animation. So if I start this again, now we get this very nice animation. I can show this again. We have this input graph, and then there's some kind of animation. This is a very nice thing to have, not only for visualization purposes, but sometimes it really helps you to understand what changes in your in the layout. So the next thing that I would like to show you is how to configure these kind of layouts. And I only will give you some basic principles about this, because in the upcoming webinars I will explain this for the layouters in much greater detail. So for example, for the hierarchic layout, we can change the layout orientation. And one typical way to configure these layouts is just to see what kind of properties they directly have and to change them. So for example, this layout has this property layout orientation. And so for example, we could say that we would like to have a layout orientation from left to right. Currently, the default is from top to bottom. So I can change this. I can again apply this, so we get this input graph, and when I press the button, what you can see is that the layout goes from left to right and not from top to bottom. And this is a typical way how to configure these kind of layouts. Of course, there are also other options. So for example, you could introduce some kind of minimum layer distance. You could say that this layer distance should be, for example, 200 pixels. And if I apply this again, what you see is that between the layers, the distance increases for each of the layers. So the layouts typically give you very basic properties to configure them. And these are very simple attributes. But sometimes you would like to do more complex things. For example, you would like to introduce some properties for some special nodes or only for a few of the nodes. And then there's a different way to configure these layouts. This I would like to show not on the hierarchic layout, but on the tree layout. To that end, I changed the hierarchic layout to the tree layout. I also need to import this. Of course, some of the properties are not legal anymore. For example, there is no layer distance, but for example, the orientation. And I also need to change the example. Currently, it's a graph with cycles, and as I said before, the tree layout can only use trees as input. So for example, I just use this graph here, which is a really large graph, or it's larger than the graph before. And now what happens is that the layout creates a tree structure for this graph. And now, for example, one idea could be that you would like to change the root node of this graph. And here, what you can do is that you actually can specify one node that should be at the top of the graph. So normally this is done automatically. So yFiles, the layout algorithm, determines a node that should be a good choice for the root node. But in some use cases, maybe it's better to define these roots on your own, because you know this must be the node that is at the very top of this layout, and then you need to specify this. However, if you look at this layout object, you won't find anything that says that you can define the root. However, there's the possibility to configure these layouts using layout data. And this is just a further object which is called tree layout data. And if you look at this layout data, you will find further properties, and you can specify these properties. And these properties are much more complex, and you can change them with different strategies or with different ways, in different ways. So for example, I would like to change the tree root node, and to that end, there are different possibilities. There are so-called delegates, where you basically introduce some kind of filter, and in this particular case, you can introduce the node itself, so you can specify an item, which is basically the root node. And what I would like to do is that I would like to filter the nodes of the graph and find a node that has the label root. So basically what I would like to do next is that, for example, if I have this graph layout here, that I can go to one of the nodes and just write here some label root, and then I press layout, and then this root, this node should become the root node of this entire graph. And how can I do this? I just need to identify this node and then define this node as the item of the tree root, as the root of the tree. And to that end, I take the graph, I find, I look at the nodes, and in this nodes I would like to find a node whose label is root. And to that end I need to define a lambda function, which is also can be similarly done. Which can be similarly done in Java, for example. And the lambda function expects a node and an index, and then we need to either return true or false. We return true if it's the node that we are looking for, and we return false if it's not the node that we are looking for. So we say that this the labels need to be specified, so there must be some label, and the first label, the text of this label, should be just root. And this gives us a node, and we call this node a root. And of course, if we haven't specified any such node, it could be that this root does not exist. In that case, this method returns null. So if this root node is unequal null, we could say that we specify this as the new root node of the tree. So again, this is the graph. This is the layout without specifying any dedicated root node. And now I would like to say that this is the new root node. And if I press now the layout button, I'm sorry, this is the thing that always happens to me when I use the layout data. I forget to tell the layout algorithm that it should use the layout data. So here at this point you need to define the layout data. So you need to tell the algorithm I would like to use the tree layout, and I would like to use this special tree layout data. And I can rerun this example. And for example, I would like to have this root node, and if I now change this, now what you can see is that this node becomes the root node. And this is a very typical way how you can change or configure the layout by using these layout data. And you can, for example, change single items, but you can also maybe fix certain subsets of the nodes, so that you say, okay, the layout should only work on a subset of these nodes, and all other nodes are fixed. And this can be typically done with the layout data. So this is a concept which is very important for yFiles, and which I will also show you in greater detail in the upcoming webinars. This is basically the entire coding example that I wanted to show you. So you should have learned how to apply a simple layout algorithm, so which is quite easy. You just need to create an object and then apply it on the graph. And then the next step was to learn a bit about the layout data and how to configure this. This brings me to the last part of this webinar, namely the questions. So I I think now it's time to ask the question. I will go through the chat and we'll see which of the questions I can answer, and I hope that I can answer all of them. So there's so one question is, can you give an overview on how the edge routing works in the Cactus graph? This really looks nice. Yeah, that's really nice in the Cactus graph. If you have a look at this, you have this kind of edge bundling. And this edge bundling is the typical routing style that is used, which is also, for example, provided not only by the Cactus Group, but also by the circular layout, for example. And it's based on approaches that are really well known in the graph community. So if you look at these scientific papers, there are many papers about edge bundling, and some of them are applied in this. I hope that yeah, in the upcoming webinar on Cactus Group layouts, I can elaborate a bit on this topic. So the next question is it possible to combine different layouts? And the answer is yes, this is possible. For example, you could use so-called recursive group layout. So for example, you could assume that you are given a graph, and this with group nodes, and these group nodes contain other nodes, for example, again, group nodes and so on. And the idea of this recursive group node layout is that you have a layout that you use for the top level layout of the groups, and then you have some core layouts that you can apply on the content of the group. So for example, you could do the top level layout using the organic layout, for example, and then you could use the other layout, the hierarchic layout, to lay out the content of the groups. And this is called the recursive group layout. Another way is that, so for example, for substructure, for the organic layout, the integration is already integrated in the sense that the organic layout, for example, already can identify substructures on its own and then can use specialized layout algorithms. So for example, it can lay out cycles or trees specially instead of just using the typical organic way. There's another question which is related to the question with the Cactus graph, with the edge routing, namely, will be there special webinars about edge routing and labeling? The answer is not. So we do not plan special webinars about this, but these are very important aspects of the single layouts that will be presented. So in these presentations or in these webinars, I will also talk about these kind of edge, on how to use edge routing, how to apply labeling algorithms. All this will be also part of the webinars. And yeah, the last question, I think, so there are no further questions, is do the webinars build on each other? The answer is no, they don't build on each other. The only thing is that you should have seen maybe the overview in order to get an idea how this coding example works, but we will try to create these webinars such that you can watch them without knowing the other webinars. And I think that's all. And if you have further questions, you may also ask this question in the comment section of YouTube. So we will publish this this webinar also on YouTube, and we will always have also a look at the comments and try to answer them as soon as possible. Yeah, I think then with this I would like to end up with the wrap up with this webinar. I hope that you have enjoyed watching this, and I hope that you are also going to attend the next webinars, and until then I wish you happy diagramming. Goodbye.